tank test it and then try to test it.
You should totally do that too. No, it depends on the photo. Why don't you do something fun?
Maybe
Girlfriend, and she falls and I'm stuck.
Alright, Natalie's gonna explain how she did the bell ringer. Let's pay close attention. Let's go ahead and close our Chromebooks. Alright, Natalie, go ahead.
Okay. So, this triangle to me was not 45, 45, 90 or 60, 30, 90. So I did 3.9 squared plus b squared equals 11 squared because this is the hypotenuse. It's straight across the right angle. And I worked it out. We got approximately 10.3.
Thank you. Abby, tell us, do you agree or disagree?
I agree.
Yeah, very good. So notice on this one, they gave you one of the legs and the hypotenuse. And so you had to plug it in for A and C, and then you had to find B. And also, I like how you explained that there was nothing telling you that it was a 45, 45, 90 or a 30, 60, 90. A 30, 60, 90 would have to have one of those labeled as either 30 or 60. But a 45, 45, 90, it can either have one of these as 45, or you could also see that two of the legs are congruent. Because if two of the legs are congruent, then that makes the two angles congruent. And the only way a right triangle can have two angles congruent is if they're both 45. Okay. So it kind of ties what we're doing here to what we were doing yesterday. All right, I need you can put your bell ringer away. I need you to get out that piece of paper. And a lot of people were having trouble on yesterday's assignment, but they had pretty much the main idea of the concept down. It was while you were working it out, like solving it, it was the algebra part, simplifying radicals. So I'm going to show you a couple examples on how to simplify radicals, and you're going to copy those down, so that way when you're doing the worksheet and you're doing those independent practice problems, you will have those examples to go off of. Alright, so as I said, make sure you copy what I worked down, copy it down. Alright, so at the top, if you just want to put review, simplifying radicals, that would be fine. You're not going to have to keep this in your binder or anything, just keep it, you can if you want to. But just make sure you keep it on you so you can use it for your class assignment today, plus your assignment tomorrow, and then next week you'll have a homework assignment over it. So just make sure you have them to look back on. Alright, so first problem I need you, there's two problems on here, but just write the first one down for now. 4 times the square root of 2. 4 times the square root of 2. When you go to multiply these, the only time you can multiply a number inside a radical is if you have another radical. It's not really that they're like terms, but you can kind of treat it that way. And you also want to treat the square root of 2 kind of like a variable. So if you had 4 times x, that would just be 4x. Well, treat this like it's a variable. 4 times the square root of 2 is just 4 square roots of 2. And I can't actually do 4 times 2 because 2 is inside a radical and 4 is not. Same thing here. 3 is inside a radical, but 9 is not, so that would just be 9 square roots of 3. So you're going to treat a radical like it's a variable until you get to working with more than just one radical. Okay? For instance, let's say you had the square root of 2 times the square root of 3. Okay? Since both of these are underneath the radical symbol, I can multiply 2 times 3. Okay, so 2 times 3 is 6, so I get the square root of 6. Now what you want to do is you want to check to make sure that this isn't a perfect square. So to do that, type that in your calculator. Type in the square root of 6. And tell me what you get.
3.4.
Okay, so you get like a really long decimal. Yeah, so that means that this is irrational, so it would not have, so you would just leave it as the square root of 6. Look at this one. It's the square root of 5 times the square root of 5. You can do 5 times 5, which is 25, so that's the square root of 25. Now type in your calculator the square root of 25. So the answer would be 5 without a radical. Now, if you notice that these two are the exact same, square root of 5 times the square root of 5, that's really just the square root of 5 squared, and a square root and a square undo each other, so that just leaves you 5. Okay. Same thing, square root of 3 times the square root of 3 would just give you 3. Square root of 10 times the square root of 10 would just give you 10. Okay, try the next one. 4 square roots of 2 times the square root of 2. 4 square roots of 2 times the square root of 2. Now, I can't multiply the 4 with the square root of 2, or the 4 with this square root of 2, but I can multiply these two together. The square root of 2 times the square root of 2. So I have 4 times, what's the square root of 2 times the square root of 2? It's just 2. So you have 4 times 2. Well, what's 4 times 2? 8. Also, you could type this in your calculator. Type in your calculator 4 square roots of 2 times the square root of 2, and make sure you get 8. If you don't get 8, let me know and I'll come check your calculator and show you what you're doing wrong. So type in 4 square roots of 2 times the square root of 2, and it will give you 8. Okay. Anyone think they know off the top of their head what this one's going to be without working it out? 6 square roots of 5 times the square root of 5?
30.
It wouldn't be 60, but I didn't hear somebody say it. 30. 30, yeah, because square root of 5 times the square root of 5 is 5, so you have 6 times 5, which is 30. Again, type it in your calculator, and you should get 30. 6 square roots of 5 times the square root of 5. If you don't get 30, let me know and I'll come check your calculator. Because I want you to be able to do this on your assignment. And those of you that I didn't need to check your notes, that way when you do your notes.
Mine gives me like the number is what it's like 30 square root of 50.
Really? Let me see.
I did that on the last one too.
Oh, that's because you're doing 6 square roots of 5 times 5. It needs to be times the square root of 5.
Oh.
Same thing on the other one. You put times 2, it times the square root of 2. Alright, the next one, the next type of problem. 6 over the square root of 3. This is probably the most complicated problems that you're going to get with simplifying radicals, is when you have a fraction and the radicals in the denominator. Because you're not allowed to have a radical in the denominator. So to simplify it, you need to get rid of the radical. So to do that, you multiply it by itself. And whatever you do to the bottom, you also got to do to the top. So you multiply both the top and the bottom by the denominator. Well, 6 times the square root of 3, remember I can't do anything to that because one's a radical and one's not, so it's just 6 square roots of 3. And then the square root of 3 times the square root of 3 is just 3. Now, treat this like it's a division problem. If you have 6 fish and you divide it up into 3 groups, how many fish are in each group? 2. But instead of fish, it's square roots of 3. So you have 2 square roots of 3. So you had 6 square roots of 3. You divided it up into 3 groups, so that leaves you 2 square roots of 3 in each group. Alright, this one here, you have the square root of 2 in the denominator, so I'm going to multiply it by the square root of 2 and the top by the square root of 2. I can't do anything here, so I just leave it as 8 square roots of 2 over 2. If I have 8 fish and I divide it up into 2 aquariums, how many fish are in each aquarium? So it's 4 square roots of 2. Okay. Alright, does that right there help from yesterday? Okay. Alright, there's one other type that I wanted to show you. It's pretty much this, but a little bit different. 7 over the square root of 2. Okay. Same thing before. Multiply by the square root of 2, multiply by the square root of 2. So you get 7 square roots of 2 over 2. If I have 7 people and I divide them up and I divide them up into groups of 2, can I do that? No, you're going to have one person feeling left out. So this is our final answer. You can't do 7 divided by 2 without getting a decimal. So you just leave it like this. 7 square roots of 2 all over 2. Anybody think they know what this is going to be without us even working it out? Perfect. You multiply the top and the bottom by the square root of 5. You get 11 square roots of 5. And square root of 5 times square root of 5 is 5. And you can't do 11 divided by 5, so you just leave it. Okay, what you're going to do today is your worksheet. You need to show your work on a separate piece of paper. If you haven't gotten your worksheet yet, that means I have not checked your independent practice problems. So I need to check your independent practice problems, and then I can come around and then I will give you your worksheet. But you need to show your work on a separate piece of paper, and when you're done, turn your worksheet in to me.